Waiting for the stream to start. Let's get that going. All right. Hi everyone, this is TigerHawk23. Today I'm going to stream some Python. The plan for today is a point of sale system for something like a lemonade stand, and it's just going to be a console text-based thing. So let's get started. First I will have, how about a cash register system of some kind. About register equals 0. And I will be filling this in with functions later on when I decide what I want. For now I'm going to work on the flow. So I'm going to have while 1, and then we will start with print a message about lemonade stand starting up, and then about ready to take orders. The fun part first. Ready to take orders. Now let's do another infinite loop, and this one will have a break pretty early on, depending on when someone is done with their order. Or this one will have a continue for ending an order. So let's have order equals, let's make it a list, and we're going to append things. And we'll have, what are we going to have at our lemonade stand? First we're going to say, what would you like to order? Actually, we're going to have that be input. No, not yet. Now we're going to have a list of things they can get. How about lemonade to start with? And how about when I have strings coming together like this, just consecutively, they will automatically be concatenated into one. Glass of lemonade, glass of grapefruit juice. For now, I'm going to have the person enter just the number of the menu choice. If we wanted, we could have some kind of fuzzy matching, like if LEM is in it, they could have that could be lemonade, and grapefruit juice could just be like GR or just J. Let's have one more thing on our menu, and that would be a cookie of unspecified type, because you just get a cookie, some kind. Alright, now we can start writing it. Let's make sure they have one at a time. So we're gonna have So I want to have, I know already that I want to be able to to allow the cashier to enter multiple orders easily. Like if someone wants 5 glasses of lemonade for their family or friends, then I don't want to have to make them basically scan the same item over and over again. That's annoying. And how many? Let's actually have let's have them enter this afterward instead of splitting it. It's fine. Time, please. So we're just going to ask for input. We're going to make that an int. I know already. Actually, there's not really any need for that. Let's put some prices there. Let's make the grapefruit juice more expensive because. And cookies are $1. $1. That's great. Okay. And then right after we get the item number, we're going to get how many. And yeah, that's fine. How many? And let's see. Let's actually put this in a function, I believe. Get order. And then move this over here. Good. Do I have too many loops? I want to have this loop for different customers and this loop for different items in an order. So I want to print this multiple times. Here's what we'll do. So here's what we'll actually wrap this in a try except. Actually, no. If not item, we're going to return nothing. They will need a quantity of some kind. Great, and we'll put this in int. We'll have this be, yeah. Okay. Let's take this out of here, actually. Put the first one over there. And we're going to have item quantity equals get order. Good. If the item is 0, then we're going to break and go. Yeah. Yeah, we want this first. So we have a way to end, and if they didn't end, order.append, and we're going to do how will we specify how much of each? How about we'll have the string the number of times that they want it. So that's item times quantity. And since item is a string and quantity is an integer, we'll have, if they ordered 3 lemonades, that will be 111 is what it's going to end up as for now. Okay, and this is when they want to end. So in addition to this, we're going to do other things. How about telling them the order total and having them pay? How about that? Sounds good. Print. Glasses of lemonade. If actually, this doesn't even need to be a list. It can just be a string. Great. If one in order, print who ordered this many glasses of lemonade, and we'll just make this a 1 do new style. Lemonade, this much. And that would be format one dot count. Yeah, let's do this. Order dot count one. This is totally wrong. Backwards. Backwards. Order dot count one. And I could use a counter object from the collections module. I'm just gonna have a couple lines here. We might want to expand it later on if we had lots of potential things. Grapefruit equals order dot count 2. Cookie equals order dot count 3. Or we could do lemonade, grapefruit, cookie equals order dot count object for object in 1, 2, 3. Very good. Simple. Good. So it's going to go through the 1, 2, and 3 orders and count how many there are for each. And then this can just be if lemonade, this many glasses of lemonade, format lemonade, and lemonade times uh, 0.5, and we're going to times 50 cents. We're just going to go ahead and do that right now. And we're going to do this. Actually, no, that's not necessary here. But we will have to round it. Actually, we can do 0.02, 02 F. I think that's the format specifier. Let me check. Yeah, that's good. Cool. This times that, and we're going to print that. Glasses of grapefruit juice. Let's spell it right. And grapefruit times 0.75. And that's lemonade. So this key value format that I'm using even in the output is a way to avoid having to make a special case if there's just one of the item, because you don't want to have you have 1 glasses of lemonade. Sounds wrong. It's bad. Something this much. Cookies this many. And that. Great. Grapefruit grapefruit and cookie. All right. Let's do this. Forgot something. If grapefruit, if cookie, excuse me. Let's see, we have lemonade, grapefruit juice, and cookies. Point whatever. Okay. Actually, let's just okay, fine. Maybe. Might as well leave this as a, this will have a 0.00 for the cookies. That's fine. So total will be plus grapefruit times 0.75 plus cookie. We're going to round this off. F, that's going to be dollars. Okay. So we're going to print that. How about tax? Actually, this is all food. Let's not do tax. Let's just call it total. There we go. Total this much. And this input cash, and this is going to be input cash, and then I will be rounding everything, so floating point errors shouldn't be an issue here. But if I were doing actual calculations, something with currency, you always want to do the smallest denomination and use integers, so you avoid floating point accuracy problems. They're very precise, but you might get a number like 2.200000 and like 10 more zeros, 3. Just because that exact number might not have an exact floating point representation. But anyway, float input cash, and let's do this. Total equals, let's move this up here. Total. Let's actually try to do this. Here we're going to work in pennies here. Total divided by 100. That's good because we're just formatting it. So we're storing the actual number as is an integer, but when we display it, we're going to just use floating points, and that should be fine. Because they're rounded anyway and formatted. It's fine. It's fine. And divide by 100. Now float for the input, because people are generally going to want to do something with a floating point number. They might put like 3.75 or maybe just or 3.00 or just 3. And so we're going to just instead of checking for the decimal place and checking for other characters, etc., we're just going to have it be a float and hope that the salesperson does it right. And let's actually round this to 2 decimal places. Is that how it works? Yeah, that's fine. Equals this. So we have the input. Change equals round this, and let's see. So I want to get this floating point number, and I've rounded it. Here's what I'll do. Instead of rounding, so looks like I'll have to mess with that, actually. Input cache. Let's assume they entered something that makes sense, at least, like 3 or 3.00 or 3.75. If there's a decimal place and tendered, then if tendered ends with dot 0. No. Yeah, let's just make this the main thing. If dot 0 and okay, this might be a little more complex, unfortunately. You know what? This is the time for regular expressions. Because sometimes you want to use them, sometimes. And I'm gonna. And let's say find something in input. Digits, any number of them. And then a literal dot, decimal point. We don't want to say any character. And then there may or may not be one of those. And, no, we want to clean this up. We know it'll find it. We have to clean it. Annoying. Here's what we'll do. There. All fixed. Now the salesperson will have to do that right. And that makes it a lot easier to write. We're going to replace the dot with nothing. There. And so we have the tendered is int out of that. So we have the cost in number of pennies, in cents, and the tendered cash in cents equals total minus tendered. Very good. Dollars, quarters, dimes, nickels, pennies equals cents equals div mod. This is a handy function. It allows you to perform integer division and returns the result from the division basically and the result from the modulus. So 11 mod or div mod with 11 and 3 would be 11 divided by 3 with integer division. So that would be 3, and that would be a remainder of 2. So we would have 3 and 2 as a result. It's handy for things like this. Div mod change and 100. So that'll give us dollars and cents. And now we want quarters and remaining cents equals div mod cents by 25. And then dimes cents equals div mod cents and 10. Nickels and pennies equals, let's just make it, yeah, let's keep it a cents. It'll have another variable in memory, but it really doesn't matter. And this will make it clear that it's remaining cents and not necessarily the amount of pennies. Good. Equals div mod cents 5. Very good. Your change is $20. This many. Should we do this for dollars? We might as well. Might as well. I don't know why we would have change for 100. No. We'll just say no. Can't do that. Can't give us a $100 bill. We don't do that. We're a lemonade stand. So yeah. How about 50 and dollars equals div mod dollars 50, and then 20 with dollars equals div mod dollars 20. And then 10 with dollars equals div mod dollars 10. And 1 equals div mod dollars 5. Great. Kinda ugly, but that's the way to do it because we have all those denominations. So dollars and cents, good, and then we get the amount of 50s, 20s, 10s, 5s, and 1s, and then quarters, cent, and then quarters, dimes, nickels, and pennies. Good. Let's do the following. If 50 print 50s 50, if 20 and 20 20s with 20, if 10 print 10s, if 5 print 5s 5, if 1 print 1s, and instead of using print formatting, or sorry, string formatting, I'm just having it, I'm just sending multiple arguments to print, and the default separator is space. It's good. If quarters, right? Yeah. Quarters, print quarters. Quarters. If dimes, print dimes. If nickels, gotta spell it right. Nickels. If pennies, print pennies. Okay. Very good. All right. This is starting to seem like something I could put in a dictionary, so I'm gonna. '50s. Name 0 for name in '50s, '20s, 10s, 5s, 1s, quarters, dimes, nickels, and pennies. Dimes, nickels, pennies. All right, cool. So that'll initialize it to 0. Do I need this actually? I don't think I do. What I will do is save this elsewhere. Take out that. All right. And then denominations, user denominations. We'll start a dictionary. And then we want 50. So that's user denominations 50s, and dollars equals that. $10, $5, and 1, quarters, dimes, nickels, pennies, 20s, 10s, 5s, 1s, and we're gonna have quarters and dimes, nickels, and pennies. Very good. For this, denominations, if yeah. Equals denomination, no, user denominations, denomination, if quant, print, and that's something with something else, dot format, whatever. Denomination and denominations, which is this. So we're going to print the denomination and the quantity. I think I already used quantity elsewhere. Oh, that's, yeah. Yeah, that's how many they want. I'm not going to overwrite that. Very good. Cool. That's the best part of programming, refactoring into something smaller. Okay. So we're going to add that to 50s, 20s, 10s, 5s, then quarters, dimes, nickels, pennies. Print your change for each denomination. If they have one, because this might be 0, and if it's 0, then we don't need to mention it. So if they need to get any of that denomination, it's going to say the number of them, or the type, and then the number of them. Great. And that'll allow them to give change, and it's going to break this. No, that's not very good. No, no, no. I gotta move this out of here. Okay, so it's starting up and it's ready. And then we're going to say start a new order, and then ask what they want to order, a whole bunch. So if they have something they want to order, it's going to keep adding it, and so on and so forth. Wait. Nope. This has to be outside as well. And then reinitialize it there. Why do I have this? This is bad. I have a loop and a loop and a loop. That's not good. I don't want that. Here's what I'll do. Probably better. Okay. So it's going to initialize an empty order. And then what do you want to order? And then it's going to, this is better, to get that, to get order, and then it will, oh, I forgot to add it to the register. Change, etc., and it's the total. Forgot to put the money in the register, huh? That's bad. So let's see. If they want to continue with their order, we get the item and the quantity, and then we add it. If they just press enter instead of having an item, it'll return that. If there's no item, then we count everything up. This, order dot count, whatever, okay. Lemonade, grapefruit cookie. Could probably I don't know. Naming things is one of the hardest parts of programming. I'll get to it later. I promise. And for name quantity in zip 103 and LGC. If quantity no, that's here's what we'll do. Yeah, glass of lemonade, fruit juice, and cookies. So those together have print the name of it, and then the quantity. No, price. Quantity, price. This LGC and 0.5, 0.75, and 1. Name, quantity times price. Cool. So we're going to zip the name that we want to use with how many they ordered of each, and it'll be in the same order, with the price. And if they ordered any, we're going to say the name, and you ordered this many, and the total is this for that much. Cool. Total equals sum A times B for AB in zip let's call this quantities. That's what it is. And I'm not using this elsewhere. Good. Quantities for AB in zip quantities and 0.5, 0. What am I doing? Zero 0.5, 0.75, and 1. Okay. Better. So we're going to zip the quantities with the prices, and we're going to multiply, etc. times B for AB and zip. Very good. I wanted, gonna do it right. That many pennies. Quantity times price divided by 100. Don't need that anymore. Need this. So prices, quantities prices, equals sum of this. Add the total, and this is all in pennies. So when I print it, I'm going to divide by 100 and format it. Tendered explains the format we want. We're going to replace the dot with nothing, and change Total minus 100, good. Then we have our denominations. User denominations, we made a dictionary. Very good. Fives and ones. Print your change for each one that we have. If there's a quantity, then we print it, and we zero out the order. And we don't really need to break. Okay. Very good. Okay. Get order. Register 0, order nothing. Prices. Okay. If item equals Q, return QQ. QQ. So it'll have to be on a new customer that we quit. And if item equals Q, today, did you see that? I was going to put something with an apostrophe, and so unless I want to use escaping, which I would rather not, I'll use double quotes. Today's total is this much, and I'm going to format it with register and break. Or if a customer finished an order, I'm gonna go ahead and save this. So, all right, very good. Okay, it's gonna say it's starting up. I'm gonna move this out of here. Break. There we go. So in our loop, we're going to say what do you want to order one at a time. And then we're going to get their order for an item and a quantity. It's going to be 1, 2, or 3. And how many is going to be an integer. If item was a Q, it's going to be QQ. If they say nothing, that's done with the order. And if they say the item is a Q, that's going to return this instead. And so if item is Q, then break. If item is 0, then we're going to get the quantities. of everything in their order. So we're going to count each one. So it's going to count the ones, the twos, and the threes, make a list out of that. And it's going to zip these names. Do I have that anywhere else? No. Okay. So lemonade, grapefruit juice, and cookies. That's a little far. 106 columns. That's fine. Some people swear by the classic 80 character width, which is here. This much. It's a little narrow to me. As you can see, I don't really have a problem with going beyond that. This one is 106. It's become more accepted these days to do 100 columns or 120. If you start going to like 150 or so, that's, well, it's up to you, but the higher you get, the fewer people will enjoy reading your code. So 100 and 120 are pretty popular nowadays. This limit was originally because the terminal could only show 24 lines with 80 characters per line. So that's what it was limited to. And you literally could not have anything more than that. It couldn't be displayed. But now we can, so we can do something that we prefer using according to our own preferences. Yeah, so I'm not going to be doing 80 character lines. Lemonade, grapefruit juice, cookies, with the quantities of how many of each, with the prices for each, 50, 75, 100. And yeah, if, let me see again, if we have any of those, we're going to print the name, the quantity, and the price. It's going to divide by 100 when we format it. And then the total is going to be the sum of the quantity times the price. No, quantity times price for each one in item times quantity. What's quantity? Okay. If I overwrite it if we do that. No, I need the quantity, don't I? No, because that's just to add it. That is already very confusing. So let's number of them. Not strictly necessary, because quantity was used in the other branch, not this one. And in this particular branch of this structure, there is no quantity. It's not used. So for name, number of them, price, name, number, for name times number. This is going to make it wider, but I don't care. It's more descriptive than A and B. Single character variable names are generally bad because you don't know what they are. They make your variables variables. Like math, x plus 2, it doesn't matter what x is, it's just a number. But these aren't just numbers, they refer to something that could be real, like a number of glasses of lemonade. So we care what they're called. name times number for each one we're going to zip the quantities and prices. We're going to add the total to the register. And we're going to print the total that they ordered, and that's the total for this customer's order. Tendered is going to be, and then they're going to input cash in a format we specify, and we're going to take out the decimal place. It'd be weird to say enter the number of pennies that this would cost. We're not going to do that. Change. We're going to oh, this is backwards. That would have been fun. Tendered minus total. And if tendered is too small, then the cashier will say that's not enough money to cover this. They can figure that out. I mean, we could put if tendered less than total, then do something. I don't know. It doesn't. That's not something that I've ever seen being actually needed in a point of sale system. Denominations equals this. User nominations, that's what they have in the change. So dollars and cents is div mod change 100. And so that'll divide by 100 with the remainder. And we have 50s, and then 50s when we divide by 50, 20s, 10s, and then 5s and 1s. And quarters, dimes, nickels and pennies, 25, 10, 5. Very good. And then we're going to this is going to have to be different. If any user denominations dot values. So the values for the user denominations dictionary is the actual number of whatever denominations that they are owed. And I'm going to put this in that if as well. So if they have change owed to them, then this will happen. If not, then it means they paid an exact change, and we're not going to tell them the change. And we're going to do this. And then we're going to zero out the order. That looks reasonable. Save. I'm going to turn on the command line. Let's see what we got. Pie, lemonade, stand pie. Let's see what happens. Invalid syntax. Oops. Hehehe. Okay. If item equals. Here we go. The thing about this, Python does not allow assignments in that sort of context or situation. Other languages allow you to do exactly what I had here. If item equals and then some value. And for example, in R, if you do that, any assignment returns the assigned value. So it can be a handy shortcut, but the designer of Python decided that it's not worth the potential for errors, because assigning it is definitely not what I meant to do. So it's good that it caught it, and now I can say, oh, I meant to do an equality comparison. Of course, then you have kind of the opposite problem still remaining, where if you wanted to check a condition and then reassign a variable based on something, and you put two equal signs, then it just compares equality and doesn't change anything, which will also make your program not work. So let's save that and try again. Valid syntax. Where did I do that? 51. Oops. Yeah, that's wrong. Okay. Now it runs after a few syntax errors. That's fine. I was coding for, wow, almost over an hour without running it, so that's fine. It makes sense. What would you like to order? 1 through 3. One at a time, please. I want a glass of lemonade. That's number 1. How many? I want 2 of them for myself and for my imaginary friend. Enter. What would you like to order? I am done with this order. I'm going to press Enter. Glasses of lemonade 2. And the total is $1. And the total is $1. That's fine. Input cash. I gave them $1.87 because I feel like it. Actually, let's enter the right amount. Let's give exact change this time, because we're testing an ordinary run for now. Okay, so there's no change. Here's your lemonade. Thank you. Blah blah blah. And let's do what did I have here? Q is going to be my quit sign. So Q. There's nobody else buying lemonade today. The cashier sat there and waited and waited and waited. And we're done. Today's total, 100 pennies. 100 pennies. Today's total. All right. Let's have some more customers, shall we? I want a glass of lemonade. Let's get 5 of those. And then a couple people want grapefruit juice. And then I want cookies, and I want 10 of them because we like cookies. And that's it for the order. And we did order 5 and 2 and 10, so that's, wow, that's expensive, but that's okay. Should be $2, $3, $4, 14, great. So that's correct. And I'm gonna just give a 20.00, that's important. So the change is 5s, 1 of them, and 1s, 1 of them, which is absolutely right. Cool. How about, and that's $14 in the register right now. We're keeping a close eye on that because we don't want the employees to steal, right? How about 3 glasses of lemonade? That's going to be 75 cents. And let's finish with that and do $12.81. And that should be a 10 and a 1. Good. And then we'll use a quarter and a nickel and a penny. That's pretty good. I did dimes the same way, so I assume those will work. If this was a real thing, I would not assume. I would test absolutely everything. But I think for the stream we can say it's good, it's working, it's happy. How about all I want is a cookie. Just give me a cookie. And that's it. Here's my dollar. Okay. And it was Q, right? Q. Management would have to train employees to say it's capital Q to quit. 16.5. Is that right? I don't know. Wasn't really keeping track. Total. So we have $1 and $2.50, $16.50, 16.5. All right. And I'm gonna format it with .0. Oh, it's not the letter O. Yeah. %.02f. That'll save that. Let's go back in here with, let's see, 1 glass of lemonade. And then that's it. And tender 0.50. And ooh, here's something. We are replacing the comma. We're replacing the period with nothing, and then changing that to an int. Let's also remove any extraneous zeros from that. Yeah. Because if we had 0.50, then that would turn into 0.50. And leading zeros are something that Python has used at some points in the past to indicate that the number is octal. We don't want that. We don't want that today, right now. It's not bad to have other other base systems in use. That's fine. Can you imagine raising someone on hexadecimal? Instead of teaching them to count 1 to 10, you teach them to count 1 to F. To count 0 to F. Teach them 0 indexing. Then they wouldn't be able to do anything. Let's see, we have that. I inputted the cache. Okay, now I'm going to say quit for the day. And the total is 0.50. I'm going to add a $sign. Dollar sign, very good. Okay. Cool beans. So, it's pretty nice, I think. Asks what they want. Clear directions. Of course, if they mess up, they're screwed. But that can be perhaps something for another day. There is no limit to the amount of error checking you can potentially do, because there can be an infinite number of ways for someone to mess up your program. Yeah, it's yeah, that's what testing is for. I've heard that good testers are very, very valuable because they will find fascinating new ways to break all your code over and over again. But for this, I think it's pretty good. Have a bunch of div mod. For this area with the user denominations, finding everything, it would I could make more iterables with 50s, 20s, 10s, etc. and the values for each, do that in a loop. I just don't see the don't see a huge benefit to that over here. And also there's the ones that's remaining. So I'm just gonna leave that right there. It's pretty clear what it's doing anyway. I like that. If any of these printed, and if there is one, then say what they need. Order is this. Yep. Very nice. Okay, let me take this out, and that's kind of a longer program than we've been writing for the rest of this week, but still under 60 lines. It's not very long. Of course, in Python, long code is the exception to the rule. If you have a huge code base, it better be because you're doing something very amazing. Because as you can see, there's a lot of stuff you can do with very little code in Python. That's one of the reasons I like it. It's very concise. I've someone in chat. Hi there. What is this? This emoticon. Is that a hands clapping? Keep going. Yeah. Sorry for not noticing earlier. I was very focused with finding these errors. But thanks for joining me, Shahab. And I think that's it for the stream. And yeah, thanks for watching. And I will have more Python next week. Alright, I'm going to end the stream. Thanks again, and have a good one.